Should you move your company to the moon? No, probably not. The only industries that might consider moving to the moon are ones that would benefit from the moon's natural environment because they either use a vacuum state somewhere in their manufacturing process or would benefit from low gravity. Advanced electronics, semiconductor manufacturers, pharmaceutical, bioresearch companies, telecommunications, optical and precision instruments, and material science and metallurgical component manufacturers. It's a relatively short list, but you might notice these are all very high value-add industries. On Earth, inducing vacuum states is necessary for not just vacuum experiments and sensitive instruments and carpet cleaning, but also for manufacturing processes. But inducing these conditions on this warm, wet, and wild planet can be expensive. On the moon, it's free. Semiconductor manufacturers could flourish in this environment, benefiting from the vacuum conditions essential for processes like ion implantation and chemical vapor deposition. The pharmaceutical industry would also gain lots of local lunar advantages from efficient vacuum distillation to vacuum filtration, and even freeze-dry vacuum packaging. Plus, Big Pharma can do all its favorite kinds of wacky world-ending shit on the moon since there aren't any wet markets for experimental viruses to escape into. Industries involved in metallurgy could capitalize on the lunar environment for processes like vacuum arc melting, vacuum sintering, and induction melting to produce high-purity alloys with enhanced mechanical properties. Industries focused on vacuum heat treatment, vacuum casting, and vacuum forming will find the moon's vacuum environments particularly sucky. The lunar vacuum would also be useful for coating processes, enabling the deposition of thin films with improved adhesion and uniformity, and for the production of high-precision optics such as lenses and mirrors. Almost all of the industries that would benefit from the free vacuum state would also benefit from the moon's relatively low gravity. Semiconductor manufacturing will again benefit as lower gravity results in better crystal growth, typically growing bigger, more rigid, and ordered crystal structures. Pharmaceutical companies would also receive benefits from the low gravity, as the effects of gravity can influence the growth and behavior of cells and tissues. Low gravity would improve bioprocessing and bioprinting, the process by which artificial organs are created. The absence of gravity-induced convection can result in more precise control over the solidification process during metal casting and the drawing process during the production of high-quality optical fibers, resulting in fibers with improved optics and alloys with enhanced properties. The lack of atmosphere and low gravity also means that shipping anything from the moon to the Earth's surface takes less time than shipping things across an Earth ocean. Are you paying attention, Amazon? South Africa to China shipping typically takes 30 to 40 days without delays, and shipments have to arrive in a designated port with all the necessary coastal infrastructure. Anything shipped from the moon can land literally anywhere on Earth by adjusting the descent trajectory. This means inland hubs can be set up outside of every major city. Imagine landing tonnage outside a remote town in the middle of Wyoming or Alaska, or near any industrial center, significantly reducing the need to truck things across continents. According to the Tsiolkovsky rocket equation, velocity change, or delta V from the moon's surface to low Earth orbit, is 6.4. Delta V from the Earth's surface to low Earth orbit is 9.3 to 10. In other words, it's easier to get into orbit around the Earth if you start from the moon than if you start from Earth itself. This means the recent telecom trend towards mega constellations like Starlink and Project Kuiper bodes well for all your local lunar satellite manufacturing companies. Also, space probes and massive telescopes for science. Not just satellites, but space stations too will increasingly find themselves created on the moon. Any space platform or vehicle, satellites, and stations can be made much larger and much more rudimentary, as no aerodynamic designs will be needed. This is unfortunate for fans of sleek spaceship designs, as future spacecraft will literally just be giant gas-filled boxes and rectangles. Think cargo containers with a rocket engine and thruster configuration. Companies pay premiums for skyscraper real estate. Gotta get that highest office, and what office is higher than one orbiting the Earth? Likewise, private space stations will be commissioned similar to super yachts. Super yachts are expensive, inefficient, and, on the open ocean, unpleasantly bumpy rides. Yet, to the super rich, they actually are good investments. Yachts provide social spaces where business deals are often made, and between the deals cut and the valuable relationships curated at yacht club bars, the investment quickly becomes worth it. As one new yacht owner told The New Yorker, one deal secured on board will pay it all back many times over. Likewise, we'll see the rise of orbital hotels for peasants like you who can't afford their own private space station. Why travel somewhere to see something when you can travel everywhere and see everything? And I'm sure I'm going to get some comments about how we should just skip the moon and go straight to asteroid mining. Well, if the point is to turn those asteroids into stuff, then if you're already making stuff on the moon because of certain market advantages it offers, then it makes sense to process those asteroids where the stuff-making machines are. Ultimately, the moon's greatest utility will be to serve as humanity's first celestial shipyard. If you want to build a generation ship or an O'Neill cylinder, or set up Venetian cloud cities, it makes sense to build all those things on or near the moon where the capital base is. But now we're getting ahead of ourselves. The first craft you should build on the moon is an orbital refueling platform for incoming starships. Currently, SpaceX plans to launch 2 ships to orbit for lunar missions and beyond. One as the actual craft full of people and cargo, and another as a big fuel tank to top off the main ship before it starts its voyage, replacing all fuel used to reach orbit. This obviously adds to the cost, but if you were to build a giant steel box on the moon out of electrolyzed lunar regolith, fill it with fuel and launch it into orbit around Earth, then voila, you'd now be the proud new owner of the first and last gas stop between Earth and any other destination. Also, you'll need a fuel tug to ferry liquid oxygen produced from the lunar regolith electrolysis back and forth from the moon to the station. So if these are all things we can do on the moon, then why haven't we? Well, simply put, launch costs. But I think those will be coming down soon. And when they do, what next? Should you start working on a presentation to present to your company board arguing the merits of offshoring so hard you leave the atmosphere? Well, not yet. First, we need to develop the moon a bit before we start to industrialize it, a topic which could fill an entire book. I know, because I literally filled an entire book with this topic, so it's obviously too long for this video. But if you ever learned how to read and still remember, then congrats, you're qualified to pick up a copy via the links down below. And if you never learned to read, or just don't remember how, then that probably makes you Gen Z, but that's okay too, because I just so happen to have finished recording the audiobook of How to Develop the Moon, which should be coming out soon, if not already, by the time this video is released. It's low-key bussin' though.